Hello everybody, here's Mr. Z. This is a short recording for Lab 904 about magnetic fields. I'm diving right into the animation. You can do the practice. Here's our work desk. What we have here is 3 bar magnets, and we have 3 disc magnets, or they're also called circular magnets. And then on the left side here, this is a petri dish, like a glass dish. If we were to look from the side, it has a certain height, and then it has concentric circles. What we can do with it, we can place it on top of things, and that will help us, because what we'll do there actually is we're going to sprinkle these ion filings on top here, and then we want to see the magnetic field. We only need to do this ion filing sprinkling business once, because once they are sprinkled nicely, we can just use that petri dish. And I do it just for the first part now. Show you how to do this. So we're going to check the magnetic field of a bar magnet. Let's just grab this one, and in this whole lab you want to be away from the other magnets, otherwise it will not go nicely. So I'll move over here, so I'm really far away from everything else. I'm going to move the petri dish, the inverted one with the circles right over it, so that the center circle is in the middle. Dropping sometimes is a bit tricky. I want to see that. I do it 3 times now. Oops, that was off. I think that's a little bit to the left. Okay, that's perfect. And now we use the ion filings. And watch me how I do it. One of the biggest mistakes is to use too many. So you want to go in kind of a pattern. I'm now lining it up in the center of it, and I click once. It's going to make a sprinkle of ion filings. We already see a little bit of a pattern. And now I go around in a pattern, so that we have kind of equal density of filings. As you can see, I go one circle, I always line them up. I don't want to have too many, I don't want to have too little. Maybe a bit too much, but now I go around here. One in the center, and one on the right. And we do the same thing on the bottom. This is, by the way, the trickiest part. If you over sprinkle, you're not going to see the field lines too well, and we're going to fill out the outer parts too here. 1, 2. You have infinite amount of sprinkles, by the way, like the perfect birthday sprinkle cake here. You might argue you should put one more here. Okay, that looks okay. And you only need to do it once. That's the nice part. So if you have to start over again, once you have it nicely, equally density distributed, you're all set. And by the way, be happy that we do it in a virtual lab, because this is pretty messy. Ion filings is a fine powder. We have also this small compass there where we can investigate the magnetic field now. And that's useful, because in the first part, what I want you to do is basically take a screenshot of the petri dish with the magnet, and then draw me 2 field lines. Draw me 2 field lines, and remember that the line, and then arrows on it. So the lines come out of the North Pole and go into the South Pole. Okay, so, and if you want to investigate those lines, you can use this little compass. So if I start here in the North Pole, I see that the South Pole of my little compass is lining up with the North Pole. But if I go around here, you'll see basically turning, it's like steering a ship, right? And then the North Pole, the red one of the compass, is lining up with the South Pole of the bar magnet. So what I want you to do is, I can demo it here with this ink pad kind of thing. Let me grab a color here. Let's grab blue. So now you investigated a little bit with the magnet. I think you have an idea of what's going on. Maybe one line could be just like, okay, I follow up here, goes around there, goes around there, comes back in here, right? And it comes out of the north, and it goes into the South Pole. Okay, make about 5 arrows there. You can make the arrows bigger if you want, and you can go all fancy into this in Word itself. Okay, And that's about it. So you're going to do a screenshot of this part and put that into the lab report. Okay, get out of here. So the second part in the lab is then we're going to set up 2 bar magnets, and for that purpose, until we place it, we just move the petri dish aside, drop it anywhere, drop it, and drop it there. Move it even further away. The second part is to move 2 magnets opposite poles together. So we need to find 2 magnets with opposite poles. So to do that, we need to get these 2 magnets over here. As you can see, I need to move this one out of the way, the furthest away as possible. And it needs to be 2 centimeters apart. You can use the ruler there, drop it, and then zoom in, zoom. Okay, if I go to the right here, see that the ruler falls down here. It's a bit tricky. I see 6.5, so this should be around 4.5. A little bit further to the right. If you move it too far, you don't have. If you move it too far away, you don't have enough interaction. So this is about 2 centimeters apart. Don't need to overstudy. We're not measuring anything like magnetic field strength or anything like that. We get the stuff out of the way, and now we place the petri dish right on top, and with the center of the petri dish right in the middle between the 2 magnets, so about there. Okay, and now you can investigate again. You probably see already some pattern here. Here seems to be a high concentration at the poles, right? And then a high density of lines, and then it seems to bend out here and back in there. So this is probably one way to look at. It's also maybe interesting to see there's going to be a straight line here in the center, right, from left to right. It's a bit tight. I mean, there you can just make one arrow if you choose that one. You can also see that further out, it's really no difference between 1 or 2 poles, because this south pole interacts with that north pole, right? That gives you another option. And I'm just moving now to the next setup where we have 2 of the same polarity. You can use the north or the south pole, 2 centimeters apart. You put the petri dish on top. Make sure you measure it again. It's kind of the same, and see how the field looks now. Okay, now they are repelling each other, right? And of course, an interesting line would be this one where it goes out from the north pole and it shoots up, right, very high, and it comes back down here basically, right? Because it goes up here all around and back in here. Field lines always need to have closed loops. You know, they are not stopping anywhere. Just because the petri dish finishes here, we're just stopping making it visible, right? So it would leave here, come back on the bottom if you want to investigate that one. The last part is we're going to do one of the circular magnets. You can see how they interact here. We only need one. Place it right here, and a little bit close. No, I'm away. Looks very symmetric here, right? Seems to be going out and into the infinity. Again, remember that at the end these field lines don't stop, right? They must make a loop. So remember that we just, in this case, look down from the top, and the 2 poles on the circular magnet are, one is on the top and one is on the bottom, right? So we kind of intersecting the field at a certain plane above the magnet, and we'll see this pattern here. Maybe you can explain that to me. You cannot draw the closed loop here, but you should explain to me what's going on there. This is the 4th part of this lab. It's always fun. I like to play around with it a little bit. The sad part is that we can't do any sort of measurements in this lab, but there's always a solution to that, and I combine it with the need for giving you another chance for extra credit here. This is the last lab we're doing. There's no lab in Unit 10, and there's no extra credit in Unit 10. We're getting close to the end of the semester, you know, things get very busy, you try to catch up on things. So I'll put the extra credit opportunity right into this lab, and we're going to use a FET lab, and it's really extra credit, 12 points. You're going to investigate this bar magnet, and this time we're going to measure the strength and the direction of the field. This is how it comes up. Be careful, we're not investigating the coil here, but the bar magnet. You can do a reset, and then it looks like this. We don't need the compass. We need the field shown, but we need the field meter. This is an interesting device. Wherever the crosshair is, it shows us the magnitude of the field in Gauss, so 0.99 Gauss, and it shows it the angle, 38.43 degrees. So so this is 38.43 degrees, and you can look a little bit here. Now it's 92 degrees. So if the red ones, if the north poles point up, it's 90 degrees. If they point down, it's minus 90 degrees. So that's, you can investigate that. What I want you to measure is along that 1 centimeter line, 1 centimeter away from the bar. So this distance here is 1 centimeter, and this distance here are also 1 centimeter increments. You're going to investigate that line, and you're going to measure the B field, the magnitude of it, and the angle. We're not interested in the X and the Y component. So you would start maybe a little bit out here, where it's still somewhat visible where the location is, and have a table, make a table then at 0.91 Gauss and minus 21.97 degrees. You had the first measurement. You move it over to the next one, and the next one, and next one. There are about 8 data points on top of here, and then you do another 4 or so until it really diminishes here to the right. So you're going to create a table. Let me create a table so you have an idea how this thing looks like. A marker here. I use maybe yellow. Create a table. Oh, not bad. Straight lines. Oh, that's less straight. 3 columns here. First is the distance x, and just assume that the first data point over here, whatever you use here, there x equals 0, right? So at 0, you're going to write down the B field here in Gauss, and we're going to write in the angle theta, right, in degrees. Okay, so at 0 we had what, 0.91 Gauss, and we had minus 21 degrees or something, 2 degrees, and you keep going to the right every time. So here's an x equals 1, x equals 2, 3. These are centimeters, so 1, 2, 3, 4. We can leave these in centimeters. Another lousy bracket here. We're not doing any calculations beyond that. All you need to do is then make 2 graphs. Both have the x on the x-axis. How convenient is that? The magnetic field on the y and the angle on the y, and you graph what's going on there. And it will be quite interesting graphs, both of them. They're not boring. So no straight line, no, not even a quadratic, well, part of it, but fairly interesting. And I'm mostly interested in you explaining me what's going on there, right? That's the work has to be done. So this is extra credit, 12 points. I think it's worth doing it a little bit more quantitative. That's about it for this lab. So I hope you have a good experience with it, gives you some hands-on feeling, and let me know if you have any questions. Enjoy the lab, and celebrate that this is our last lab. Don't forget to work then or turn in the honors project. Thank you.